All right, how is it going? Today we are going to learn to solve trig equations. Now, this right here, this is the first video on solving trig equations. There's typically in a trig book, there's 3 sections. Okay, solving trig equations. This is the first one. I would recommend you watch all 3 of them because it'll cover everything. This video is the basics. Okay. And I feel like if you know this, if you can do this, all the other ones are easy. But you've got to get this first. All right. So to solve these things, we're going to start out by solving, and we're going to be in degrees. And then we're going to have some where this is going to be changed to radians. Okay, so we're going to solve some, get our solution in degrees. Some of our solutions are going to be in radians, just to mix it up a little bit. Now, the main thing to solving these equations is you get a trig function equals a number. Okay, just like we have here. See, the trig function equals a number. That's mainly how these are going to be, except the last couple of problems. We're gonna have more than just a trig function on this side, so we'll have to get the trig function by itself. Now, for the most part, to solve these things, you want to find your first you want to determine what quadrant your solutions are in. Okay. Then you want to find your reference angle, and then you find your solutions. Okay, so you want to determine the quadrants your solutions are in, find your reference angle, and then find your angles using the reference angle. Now, I know some of you that are watching this, your teacher taught you to use the unit circle to get all these solutions and everything. Forget about that unit circle. Okay, yeah, it's going to work on some of these, but it doesn't work all the time. And when we get to the problems where the unit circle isn't going to work, I'll let you know. So the way that I'm going to solve these, I'm going to solve them using reference angle. I'm not going to use a unit circle or anything like that because it doesn't work every time. All right, so let's get started. So solve each equation, and we want to find all the solutions from 0, and that should be 0 degrees to 360 degrees. All the solutions between 0 and 360. So we've got cosine x equals 1. All right. So as I mentioned, determine the quadrant you're in, what quadrants, and reference angle and all that stuff. Okay. This one, you don't need to do that. You're going to need to do it on like this one that we're fixing to work, and even this one right here. But on this one, we don't do that. If you get sine or cosine equals 0, 1, or -1, okay, that's going to be an angle on one of the axes, a quadrantal angle, like 0, 90, 180, 270, or 360. Okay, so when you get something like this, what I recommend doing, unless you've memorized these things, okay, which you should memorize them, okay, you should know the cosine, sine, and tangent of 0, 90, 180, 270, and 360. But if you don't, what I would recommend doing, we've got cosine. So sketch the cosine curve, just the basic cosine curve. And you know that's 0. This is 2 pi. This is, oh, I'm sorry. I messed that up, didn't I? This is 2 pi. This is pi over 2, and this is 3 pi over 2. And you know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. All right. So when you get something like this, you get cosine equals 1. Well, there you go. There's 1, right? And this is negative 1. Well, you can see cosine of 0 is 1. So we get x equal 0. And that's 0 degrees. And this is our answer. Now, you might be sitting there thinking, well, that's not the only answer, because you said when cosine equals 1, it equals 1 out here at 360 degrees, right? Yes, that's true. But notice what this says up here. X is less than 360, so 360 is not included. Now, if this were a less than or equal to, then you would include the 360. Okay? But the 360 is not included, and a lot of times in the directions, the 360 is not included. So that's our only solution, is 0 degrees. Okay? So when you get something like that, just draw it out. Same thing goes for sine. Draw the sine function out and see where it's 1 or where it's 0 or where it may equal negative 1 or it may equal 0. Just draw it and look. Okay? All right, so that's the first one. All right, now what about this one? Cosine x equals square root of 3 over 2. Now, what's the important thing here that we're noticing is cosine is equal to what? Positive. That's the key right there. Positive square root of 3 over 2. Okay? So let's determine what quadrants our solutions are in. So cosine equals positive. So where is cosine positive? It's positive in the first quadrant and the fourth quadrant, right? All right. So our solutions are going to be in the first quadrant. Well, the cosine of what is square root of 3 over 2? And also remember back when you learned reference angles. Your reference angle is an angle between 0 and 90 degrees, right? Your reference angle is in the first quadrant. And one of our solutions is in the first quadrant. So in this problem, the reference angle is one of your solutions. You see that? So here we get x is equal to, so the cosine of what? 30 degrees. That's one of the ones you should memorize. You should know sine, cosine, and tangent of 30, 45, and 60. All right, as well as 0, 90, 180, 270, 360. If you've been watching these videos, you've heard me say that a lot. Okay, you're probably sick of it. But it's, that's how you get through this stuff. You got to memorize those. All right, so there's our solution. There's one solution. That's our first quadrant solution. And it also happens to be the reference angle. So now we need to get our fourth quadrant solution, right? X is over here in the fourth quadrant. There's x. Now how do we get that? We get it by using our reference angle. So here's your reference angle, 30 degrees. So that means x is equal to, so we go all the way around to 360 and subtract off the reference angle. And so that's 330 degrees. So our solution in the fourth quadrant is 330 degrees. All right, everybody good with that? So remember what I said. Determine what quadrants, find your reference angle, and then find your solutions using your reference angle. This problem, one of our solutions was in the first quadrant, which so happens to be our reference angles in the first quadrant, so our reference angle was part of the solution. Okay? If you're still kind of fuzzy on this, just hang with me through the video. Okay? Just hang in there, and I think by the end it'll make a lot of sense. Okay, it's going to be worth the time for you to watch this. Okay, I think you'll get it after you watch the whole video. All right, let's look at the next one. So we got cosine x equals negative 1/2. Okay, so this one's what we're going to do the same thing, but we've got cosine equals a negative number. Okay, so let's determine what quadrant we're in, or quadrants. So where's cosine negative? Well, cosine is negative in the second and third quadrant. All right, second and third quadrant. So in this one, remember your reference angle is an angle in the first quadrant. It's not part of the solution. You see that? But we've got to find our reference angle. Well, how do we do that? Well, we say cosine x. Well, let me erase that. We say cosine prime x, and I put the prime because the prime represents the reference angle. See, I didn't put the prime up here because, I mean, yes, that's the reference angle, but it's also one of our solutions. But this time I'm going to make sure I denote this as the reference angle because it's not part of the solution. Okay? So the cosine of the reference angle is equal to positive 1/2. Because remember, whenever you take the sine, cosine, or tangent of an angle in the first quadrant, it's always positive. Okay, it's always positive. So here I get my reference angle is equal to 60 degrees. The cosine of 60 is 1/2. All right. All right. But keep in mind, it's not part of our solution. Our solutions are in the second and third quadrant. All right, so let's find our solutions. So we've got x equals. So let's draw this. Let's put this in the second quadrant. And there's x. Okay, so we're going to find our solution in the second quadrant. We've got to use our reference angle. Our reference angle is 60 degrees. Okay, so let's get what this angle x is. So x is equal to, so we're going to go all the way around to 180. And then we subtract off this 60 degrees, minus 60 degrees. And that is 120. So one of our solutions is 120 degrees. All right, so now let's find our solution in the third quadrant. So there's x. Here's our reference angle. All right, remember your reference angle is always measured off the x-axis. You should have learned this back at the beginning of trig. And so we get x is equal to, well, that's going to be all the way to 180. And then we're all the way to 180 plus the reference angle plus 60. So that is 240 degrees. So that's 240. And there's your solution. All right. That's all it is to it. Even in the next videos, when we get to the more difficult problems, this is how we're going to solve them. The only difference there is we've got to get it in this form here first. And then once you get it in this form, it's all worked out the same. All right. So I'm telling you, reference angles, you've got to know reference angles. Now, could you have done this using the unit circle? Of course. You know where the negative 1/2 is on the unit circle, and you know what cosine is. Yeah, you could have used it, but you're going to see in a minute that unit circle is useless. Okay. All right. Now let's look at this one. Okay, so now we're going to solve this. Okay, we've got some angles that are in not angles, but some problems there. These are in terms of sine. Whether it's in terms of sine, cosine, it doesn't matter. They're all work the same. But notice what it says here, that we want our solutions from 0 to 2 pi. So what they're telling us here is they want our answers in radians. Okay, the answers in radians. So remember what I told you about sine or cosine equaling 0, 1, or negative 1. That's going to be one of those quadrantal angles, 0, 90, 180, 270, or 360. Okay, so just like we did earlier on cosine, I would draw out the sine function. And let's label it. There you go. And here's 1, and here's -1. So we get x is equal to, well, where is it -1? Right here at what? 3 pi over 2. Is it -1 anywhere else? No. There's your answer. Okay. All right, so I hope this is helping. And remember, 3 pi over 2, that's the same thing as 270 degrees. All right. All right, so let's go to the next one. All right, sine x equals 1/2. Sine x equals 1/2. All right, so sine is positive 1/2. So where is our solution? It's in the first and second quadrant. Sine is positive in the first and second quadrant. Is our reference angle one of our solutions? Yes, because it's in the first quadrant. So we get x. So I don't need to change this to x prime because my reference angle is one of the solutions. So x is equal to what? 30 degrees, but we know that is what? Pi over 6, right? That's pi over 6. 30 degrees, pi over 6. One's in degrees, one's in radians, same thing. All right, so that's our first quadrant angle. Now let's find our second quadrant angle. So here's x. Here's pi over 6, our reference angle. So x is equal to 180, which is pi radians, minus pi over 6, and that is 5 pi over 6. And so we've got 5 pi over 6. And there's your answer. All right. You see how easy this stuff is? It's not bad at all. I think a lot of students just make it tougher than what it is. And I think a lot of students don't do their homework, but that's a different story. I mean, you've got to practice this stuff. Okay. So far we've been cruising along. You know, all of these problems that we've worked, we could have done with the unit circle. You might be sitting there saying to me, well, we could have done all those problems with the unit circle. Why are you using reference angles? Well, what about this problem? You going to do this one with the unit circle? No. Okay. That's why I think it's important to just do them all with reference angles instead of the unit circle. But look, same thing. And what I want to do here is because sometimes it can be a little more difficult to see when you're dealing with angle measures and radians. I want to change this one up, and let's find these in degrees. Let's do this angle in degrees for this problem, and then we'll get back to radians. And then I think I have another one like this where it's a decimal where you can't use the unit circle. I think I have another one like this later on where we'll do it in radians. But let's just do this one in degrees so you can see what's, I think you'll understand it better. So first thing, where's our solutions? Where is sine negative? Sine's negative in the third quadrant and the fourth quadrant, right? Is our reference angle a solution? No, it's not. So we need to find our reference angle. So I need to do sine x prime equals positive 0.3. Yes, I know I didn't put the 0 in front, but 0.3 and 0.3 is the same thing, okay? All right, so now I've got x prime is, or my reference angle is, now make sure your calculator is in degrees. So I'm going to take the inverse sine of 0.3, and that is 17.3 17.5 degrees. It's 17.45 and some more decimals. I'm just rounding it to one decimal place. Now, some of you may be sitting there watching this video and saying, well, how did you get the 17.5? What did you put in your calculator? Well, remember, to find the angle measure x prime, that is the inverse sine of 0.3. So you've got that inverse sine button on your calculator. It's above the sine button. You got to hit the second function key on your calculator to get to it. You just type this into your calculator, you'll get 17.5 degrees. All right. So remember, that is our reference angle. Our reference angle is not part of the solution because our solution is in the third and fourth quadrant. All right, so let's get our solutions. So let's find our third quadrant solution, which is here. And then this, our reference angle, is 17.5. And so x is 180 plus 17.5. So let's see what that is. 180 plus 17.5 is 197.5 degrees. So 197.5 degrees. All right. So, you know, that's it. That's your third quadrant angle. Now, let's find the fourth quadrant angle. That's this one. See, look, draw all this stuff out. Just draw it out. It makes it easier. That's 17.5 degrees. And yes, in the next videos, I know these are all simple, but in the next videos, we're going to look where this is like 2x or 3x in there, or x over 2, that kind of stuff. And then we're going to get some more quadratic equations where we got to use quadratic formula and all that good stuff. Okay, so, but like I said, just go through all these videos on solving equations and it covers everything. All right, so here we get x is equal to, well, this is going to be what, 360? See, all the way around, and then subtract off the 17.5. So that's going to be 360 minus 17.5, and that is 342.5 degrees. So 342.5 degrees. And there's your solution. All right. All right, so we're moving right along now. All right, so now let's work in radians now. Okay, let's get all this. All right, so here we've got tangent. We want to find all the solutions from 0 to 2 pi. And also, I know right now we're finding all the solutions from between 0 and 360 and 0 and 2 pi. And I know in some trig books and in some of the directions, it'll just say find all solutions. I'm going to go back to some of these problems and write down what the answer would be to that if it said to find all solutions. I'll do that at the end of the video. All right, so we got tangent alpha equals 1. Okay, tangent alpha equals 1. Now, I know I said if you've got sine or cosine equals 0, 1, or -1, know how we drew the graph out and we got our answers from that. Well, I didn't say anything about tangent equaling 1 because it's not going to apply to tangent. Okay? The tangent of what angle is 1? 45 degrees, right? See that? Or pi over 4. We're in radians. All right, so we've got tangent equals a positive number. So where is tangent positive? It's positive in the first quadrant and the third quadrant. Remember, all the trig functions are positive in the first. So this one's positive in the first and third. So is our reference angle a solution? Yes, it is. Our reference angle is a solution because one of our solutions is in the first quadrant. So we get alpha is equal to 45 degrees, but since we're in radians, that's pi over 4. All right, now let's find our third quadrant solution. So there's alpha, and there's pi over 4. So I'm going to get alpha is equal to, we're going to go to pi and then add on the pi over 4. And so that is 5 pi over 4. And so we get 5 pi over 4. And there's your answer. All right. I know this seems like nothing, but I'm telling you, if you get this, then you've got it. Okay, you've got it. You're going to know how to solve the rest of the stuff. It's going to be a lot easier for you. Okay. All right. So here we go. Tangent alpha is negative 1.34. All right. So here's another problem where that unit circle is not going to come in handy. You can probably tell by the way I talk about that unit circle, I don't really care for it that much. All right, so we've got tangent alpha is equal to a negative number. So our solutions are in the second and fourth quadrant. That's where tangent is negative, second and fourth quadrant. Is our reference angle a solution? No, because one of our solutions is not in the first quadrant. So I need to find the reference angle. And remember, the reference angle is equal to, the tangent of the reference angle is equal to a positive 1.34. And so our reference angle is, and once again, let me write it for you. Remember, to get that is the inverse tangent of 1.34. All right, so let's see, we got second tan 1.34, and that is equal to, and what I'm going to do here, I'm going to round this to 2 decimal places, 0.93. That is our reference angle. Remember, this, you see this number here, that's not the same as this up here. This is an angle measure. This is your angle, 0.93 radians. Okay. Now you might be saying, well, I punched that into my calculator. I didn't get 0.93. You might be saying, when I put that into my calculator, I got 53.3. And if you got 53.3, that is correct. But what's the problem? That's in degrees. We want our answer in radians, so make sure you change your calculator to radian measure. Okay? So all this is like saying, okay, our reference angle is 53.3 degrees. That's our reference angle. But remember, we want it in radians, so our reference angle is 0.93 radians. All right, so that's the angle measure. So now let's find our solutions. So we're going to get alpha is equal to, all right, so let's find the second quadrant angle. So there's alpha. Here's our reference angle, 0.93. So alpha is going to be what? Pi minus 0.93. All right, so let's put this in the calculator. So pi minus 0.93, that is 2.21. That's my second quadrant angle, 2.21 radians. All right, now let's get the fourth quadrant solution. So this is alpha, there's 0.93, and so alpha is equal to, I go all the way around, that's 360, but since we're in radians, that's 2 pi minus 0.93. So 2 pi minus 0.93, that is equal to 5.35. 5.35. And there's your solution. All right. So have you noticed the first group of problems was cosine, the second one was sine, and this one tangent. But have you noticed one thing? Every one of them's done the same. All of them are done the same. All right, so let's look at this one. We want to solve this equation here for all angles between 0 and 2 pi. Now this is what I was talking about. This doesn't look right, does it? It doesn't look like all the problems that we've worked before. So guess what? In order to work these problems, we got to get the trig function by itself. So we got to solve for cosine alpha. So that's going to be 2 cosine alpha equals 1, or cosine alpha equals 1/2. There you go. And now look, just like all the other ones. You see what I'm telling you? If you can get all of that we just got finished doing, then you can do this stuff. This is going to be the difference, is you're going to have to get the trig function by itself. And then once you do that, everything's worked just like the problems we got finished working. Work just like those after you get the trig function by itself. See, I'm trying to get you to understand how to work these things, not memorize how to work them. Okay? So what I want you to get out of this right now, to solve these trig functions, these trig equations, you got to get the trig function by itself equal to some number, and then you do what we just did. Now, I'll say this, in the next video, some of the trig functions, they may be a little harder to get in this form, but that's still what you've got to do. That's where knowing your identities and being able to do all that stuff comes in. All right, so let's solve it. So we've got what? Cosine is equal to positive, so we're in the first and fourth quadrant. Why don't you pause the video and you try working it? All right, so let's get alpha. All right, so first quadrant, cosine of what is 1/2? Cosine of 60, which is what? Pi over 3 in radians. That's a 3. It may not look like it, but that's pi over 3. So that's our reference angle, but it's also a solution because one of our solutions is in the first quadrant. Now let's get our fourth quadrant solution. All right. So there's alpha. There's pi over 3. So we're going to go all the way around to 360, or we're in radians, so that's 2 pi minus pi over 3. And that is equal to 5 pi over 3. So we got 5 pi over 3. And there's your answer. All right. All right, so what about this one? So it says find alpha to the nearest tenth of a degree if alpha is between 0 and 180. All right, so now it's wanting us to find all the solutions between 0 and 180. So all the solutions in the first and second quadrant only. Okay. All right, so what did I tell you? You got to get what? You got to get the sine alpha by itself. You got to get sine alpha equals a number. Okay, so let's do that. So that's going to give me sine alpha is equal to 5.6 times the sine of 32.6 degrees over 12.2. All right, so I get sine alpha. All right, now, before you get all excited and everything working this problem, stop and think a minute. You've just been working a bunch of problems in what? In radians. Make sure your calculator is switched to degrees. Okay? I see they want it in degrees, 0 degrees and 180, and this is in degrees. So we got to take our time and switch our calculator back to degrees. So that's going to be 5.6 times the sine of 32.6. And then we'll divide that by 12.2. And that gives us 0.247304623. Now, I know in the past and everything, and these other problems, I've been rounding the answers. I've been rounding the angle measure. But I've got to take the inverse sine of this number right here. I'm going to put all my decimals. If I have to take the inverse sine of a number, I'm going to put all the decimals. All right. So that's going to give me alpha is equal to second sine second. That is 14.3 degrees. Well, and look what I did. I did something that I told y'all to do this all the time, and I didn't do it just then. What did we forget to do? Our solutions in the first and second quadrant, because I got sine alpha is equal to a positive. So in this case, my reference angle is a solution. And this is my reference angle, 14.3 degrees. All right. Now, let's find our second quadrant solution. There's alpha. There's 14.3 degrees. So alpha is 180 minus 14.3. And so let's see. 180 minus 14.3 is 165.7 degrees. So 165.7 degrees. And there's your answer. All right, so, oh, look at this. This is the last problem here. And this is the last one. All right, so let's solve it. So I got to get the sine function by itself. So I get sine x is negative square root of 2. And man, let me tell you, I like these problems right off the bat. There it is. No solution. Well, but wait a minute. Why is it no solution? Why is it no solution? I need to explain it, don't I? Before I explain it, let's do another one. What if I say I have cosine x equals 3/2? What's the answer to this one? No solution. There you go. All right. Now let's explain. I'm going to explain it with graphs. There's sine function. And then let's just sketch cosine function. All right. We're just sketching it real rough so we can see it. Now notice all of this. The sine of all these angles along this x-axis here. The sine of all these numbers. So when you take the sine of a number along, sine or cosine, okay, these numbers here on the x-axis, that's what's getting plugged into here and here. And then you put it in your calculator and it spits out a y value. Do you notice all of our y values are between -1 and 1? Whenever you take the sine or cosine of an angle, you will never get an answer above 1. You'll never get an answer above 1 or below -1. And you can see this number is 1.5. That's above 1. That's out of the range. So that's impossible. That can't happen. So it's no solution. And same thing there. Negative square root of 2. Square root of 2 is 1.4 something. That's down here. That's outside the range. That's not possible. That can't happen. And so we get no solution. All right. All right, so now, okay, so now let's go back up here. And remember I told you, if you're still hanging around this long, that's wonderful. I hope you are. If not, you're going to miss out on some good stuff. All right, so that's finding the solutions of finding all the angles between 0 and 360 or 0 and 2 pi, depending on if we're in radians or degrees. Okay. Now, some of these problems will say find all solutions. Okay. So how would we do that? Well, do you see the way that we worked all of these? That's what you do first. Okay? That's what you do. You find your angles just like we've been doing. And then to list all solutions, you take the angle 120 plus 360K, 240 plus 360K. All right? Remember, sine and cosine, that's a periodic function. It has a period of 2 pi. It repeats every 2 pi. And so there you go. So see, a solution, K, and let me say here, K is any integer. All right? K is any integer. So if K is 0, then there's your 120. If K is 1, what's 120 plus 360? What is that, 480? If K is 2, then that's 120 plus 270. Or if K is negative 1, that's 120 minus 360. Or 120 minus 720 if K is negative 2. Okay, so see, it gets you all the solutions going around. So you just take each angle measure that you found and you add this 360K to it. That goes for sine and cosine. All right. So what if we're in radians? Well, big deal, right? If it says find all solutions, well, it's the same thing. You take each of these angle measures and add 360. So this is going to be pi over 6 plus what? 2 pi k. You're just in radians. 5 pi over 6 plus 2 pi k. That's all solutions right there. That's what they mean. And of course, k is any integer. All right. So what I've been talking about here is sine and cosine. What about tangent? How does tangent work? Well, remember, tangent is a periodic function with a period of pi units. So to find all solutions here, that's what? Pi over 4 plus pi times k, or 5 pi over 4 plus pi times k. And, and of course, k is any integer. Now, and then just keep in mind, if that's in radians, if it were in degrees, you would add what? 180. That's if it's in degrees. You would add 180 degrees times k. All right. So, man, I hope the video helped you. Like I said, if you're still hanging around, watch the other two. Okay? Watch the other two. It's going to cover everything on solving trig equations. And when you get finished with all 3 of the videos, you will be a master at solving trig equations. Okay? So, I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. And I will see you later.